Good morning, y'all. Is this live? Yes, we are live. Good morning, y'all. I'm gonna try to do this episode, lesson, class, whatever you want to call it, at this point, without saying "all right" 20,000 times like the last one. I watched the last one and I said "all right" like every other word, so I'm gonna try to cut down on that for this one. Sorry, I'm getting this up a little bit late. You'll have until Sunday night to finish these questions. Won't be anything that you're not capable of. And if you need extra time, just let me know. I'm flexible on that. Let's go and get started here. So we're going to start, we're going to be doing stoichiometry, but we're going to start throwing in gases. Okay, so we're going to start using liters in these conversions, which we have not done before. So we have our equation here. If we have 38.22 liters of H2SO4 at STP, which means standardized temperature and pressure, how many grams of water will be produced? It's important they tell us STP, because if they give us a specific pressure, specific temperature that's not STP, then the problem changes and we have to use the ideal gas law. So we'll get into that later, but we're not going to get into ideal gas law today. We've already used ideal gas law, but now in how should I say this? In the future, we're going to start using ideal gas law with these stoichiometry problems combined. But for now, we're just going to continue doing our stoichiometry conversions, but we're going to throw in liters now. So let's go ahead and identify what we need to do. So we're starting, it gives us 38.22 liters of H2SO4, and we're ending in grams of water. Remember last time we learned about molar ratio. So we need to write this down. So because we're going to make that bridge, we're going to have to make that bridge to make that jump from H2SO4 to agua, water. So for every 1 mole of H2SO4, I have 2 moles of water, H2O, water, same thing, based off this equation. So there's an invisible 1 here. So for every 1 mole of H2SO4 in this reaction, I have 2 moles of water being made, and that's my molar ratio. This is my bridge I'm going to use to cross from one substance to another in my problem. Let's go ahead and draw our beautiful line. Oh, that's an ugly line. Let's go and make a beautiful line. I want to make this full screen. I don't like this in non-full screen. How do I go full screen here? I guess I can't go full screen with this. Can I go full screen? Let's see. Enter full screen. There we go. Hey, okay. I want to get rid of this ugly line. I want to make a amazing line like that. There we go. All right. Oh, I just said it. Bada bing. Oh. Bada ba. If I have to add extra, I will. Let's go ahead and put over here what we're starting with. Start. So we are starting with 38.22 liters of H2SO4. So one thing that's going to help us here is it's common knowledge. You're going to use this for all the gas stoichiometry problems, is that 1 mole of anything at STP, standardized temperature and pressure, is going to be 22.4 liters of that substance. So remember, liters is a unit that we're going to use to measure how much space. It's a value measurement, so how much space something is taking up. So 22 point, you often see it with liquids and gases. So 1 mole of anything is going to be 22.4 liters of that thing at STP. So if we have 38.22 liters of H2SO4, I need to cancel out liters of H2SO4. So down here, I have to put liters of H2SO4. Well, given this new information that we can use for our problems like this, I can put 22.4 liters H2SO4. It's going to be 1 mole of H2SO4. H2SO4. So 22.4 liters of H2SO4 equals 1 mole, given the new information that we just found out. That can help us. Now we have 1 mole of H2SO4 to up here. I have to get rid of moles of H2SO4, so I need to put that down here. And now is a perfect time to go into my bridge, my molar ratio, to cross over to water, H2O. So for every 1 mole of H2SO4, I'm going to have 2 moles of H2O, water. And I got that from my equation up here. There's an invisible 1 here, and there's that 2 right there. Now I need to get rid of moles of water. Remember, I'm ending in grams of water. So I'm going to put 1 mole of water down here. And then I'm going to put the molar mass of water right here, grams of water. So let's go over here. My best friend Wolfram alpha, H2O. According to this, the molar mass is going to be 18.015. Let's round it to 18.02. Let's see here, 18.02. All right, grams of H2O. So now I have my ending point here, my grams of H2O, which is what I wanted. Now let's go ahead and cancel out. So liters of H2SO4, liters of H2SO4 cancel out, moles of H2SO4 cancel out, moles of H2SO4 cancel out, moles of H2O cancel out, moles of H2O cancel out, and that leaves me with my answer and what I'm looking for, grams of H2O. So according to my calculations, let's see here, if we have 38, ooh, let me go ahead and put this in my calculator. So 38.22 times 2 times 18.02. All right, and divide, I said, okay, divide by 22.4. My answer is going to be 61.49 grams H2O. Remember, we multiply everything on top, get that X, all right, multiply everything on bottom, we get Y, and then we're going to divide X by Y to get our answer, and our answer for this one is going to be 61.49 grams of water. So that's how we do these type of gas stoichiometry problems. We're really just adding in this 1 mole equals 22.4 liters of anything at STP. That's the main difference here. Let's go into a new one. Let's do another problem. Bye bye, 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 goodbye, goodbye, goodbye. I think I only said all right maybe 3 times or 2 times in that problem, so that was a lot better than last week. So there we go. Here's our same equation. If we have 88.62 grams of NaHCO3 at CP, how many liters of H2O will be produced? Let's go ahead and take a look at this problem. So we're going to start. Let's go ahead and label what we're starting with and ending with. So we're starting with 88.62 grams of NaHCO3, and we're ending in liters of H2O. We're going to get our molar ratio, our bridge ready. So for every 2 moles of NaHCO3, we will have 2 moles, moles of H2O, and I got that from my equation up here. So for every 2 moles of NaHCO3, we have 2 moles of H2O. This is going to be my bridge I'm going to use to cross over from one substance to another. Let's go ahead and draw our beautiful, beautiful line. So, boom. Oh, that's a rectangle. I don't want that. That's ugly. All right, here we go. Oh, I just said all right. That's not good. Bada bing, bada boo, bada bing, bada bing. I'll add more if I need it. So we're starting over here with we're going to start with 88.62 grams NaHCO3. Down here, we're going to put the molar mass of NaHCO3, which is 84.06 grams NaHCO3. Remember, I need to get rid of grams of NaHCO3, so I put grams of NaHCO3 down here. So now up here, I know that that's the molar mass, so I can go and put 1 mole of NaHCO3. Now I have 1 mole of NaHCO3 up here. NaHCO3 up here. So I need to get rid of that and put 1 mole, or I need to put moles of NaHCO3 down here. So and I can use my molar ratio, my bridge, to cross over from one thing to another. So if I were 2 moles of NaHCO3, I have 2 moles of agua, water, according to my equation, my molar ratio. Now we're looking for liters of H2O. That's going to be where we're ending with. So remember that new information we learned in the last problem. 1 mole of something at STP, standardized temperature and pressure, is going to be 22.4 liters of that thing. So we can go and put 1 mole of H2O. It's going to be 22.4 liters of agua, according to that new information. So let's go ahead and cancel things out and see what we're ending with. So grams of NaHCO3, grams of NaHCO3, moles of NaHCO3, moles of NaHCO3 cancel out, moles of H2O cancel out, moles of H2O cancel out, and that leaves my answer in the unit I want, liters of H2O. We can go ahead and write N over here, because that's where we're ending with. So we're going to multiply everything on the top. We're going to get a number known as X. We're going to multiply everything on bottom, get a number known as Y, and then we're going to divide X by Y, and that's going to give us our answer. So, according to my calculations, the answer would be 23.61 liters of H2O. You multiply everything on top and divide it by everything on bottom. So let's do one more. Now we're going to add an Avogadro's number for these type of problems. So let's go ahead and do one more example, and now we're going to add in Avogadro's number. And then after this example, you can go play TikTok or Minecraft or Roblox or whatever y'all play, Snapchat, Instagram, Facebook, MySpace. Y'all didn't have MySpace. MySpace was back when I was in high school. I don't even know if there is MySpace anymore. Bye-bye, bye-bye. All right, let's get rid of all that. Let's go ahead and add what I need to add here. Let's do the same equation, different problem though. Here we go. Okay. All right. Oh, I just said it again. If we have 29.67 liters of H2SO4 at STP, how many atoms, let's go molecules, of Na2SO4 it's not good. All right, yeah, it is. We're good. All right, how many molecules of Na2SO4 will be produced? Okie Smoky. Let's go ahead and label what we're starting with and ending with. So we are starting with 29.67 liters of H2SO4, and we're ending in molecules of Na2SO4. Let's go ahead and do our molar ratio, our bridge that we need to do this problem. So for every 1 mole of H2SO4, we are going to have 1 mole of Na2SO4. That's going to be our bridge that we're going to use later. Let's go ahead and make our beautiful line. Bada bing, bada boo, bada bing, bada Cool. If I need more, I'll add more. I haven't had to add more yet. We'll see if that ever happens. So we're going to start with whatever we got over here. So we're starting with 29.67 liters of H2SO4. I need to get rid of that. I need to get rid of those liters of H2SO4. So remember, 1 mole of something at STP is 22.4 liters of that thing. So I can put 22.4 liters, all right, of H2SO4. I said all right again. H2SO4 down here, because I need to cancel out liters of H2SO4. And I know that equals 1 mole H2SO4. So I need to get rid of moles of H2SO4. So I'm going to bring that down here. And now is the perfect time to go into my molar ratio, my bridge, to cross over to the next thing I need, which is Na2SO4. So I'm going to put 1 mole of H2SO4 down here. For every 1 mole of that, I'm going to have 1 mole of Na2SO4 according to my equation. Remember, there's invisible ones in front of those blank spots. Now it's asking me how many molecules of Na2SO4 will be produced. Remember, Avogadro's number 6.02 times 10 to the 23rd will be the number of molecules of 1 mole of something. So 1 mole of Na2SO4 is going to be 6.02 times 10 to the power of 23rd molecules Na2SO4. And that's what I'm ending with. Right here, that's what I'm ending with. So remember, Avogadro's number, very useful for problems where it's talking about atoms or molecules. 1 mole of something is going to give you 6.02 times 10 to the 23rd atoms or molecules of that thing. So Avogadro's number is going to be very useful for these type of problems. Let's go ahead and cancel out units and see what we're left with. See here, liters of H2SO4, liters of H2SO4, mole of H2SO4, moles of H2SO4, moles of Na2SO4 cancel out, moles of Na2SO4 cancel out, and that gives my answer. And ooh, I don't like that. Go away. That gives me my answer in molecules of Na2SO4, which is exactly what I want. And according to my very extensive